The oxygen sensor, also known as the O2 sensor, is a vital component located in the exhaust system. It measures the amount of oxygen present in the exhaust gases after combustion and sends that data to the car's computer. With this information, the ECU can determine whether the engine is running a rich or lean mixture. It then makes real-time adjustments to fuel injection and ignition timing to maintain the ideal air-fuel ratio for efficient combustion. Modern cars often have multiple oxygen sensors, one before the catalytic converter to monitor combustion and another after the catalytic converter to monitor its operation. The boost pressure sensor is mainly found in turbocharged and supercharged engines. Its job is to measure the amount of air pressure or boost being forced into the intake manifold by the turbocharger or supercharger, and send that data to the car's computer. With this information, the ECU can precisely control fuel injection, ignition timing, and turbo operation to maintain the right air-fuel ratio under different driving conditions. When boost pressure is high, the ECU adds more fuel to match the extra air, giving the engine more power. When the boost is low, it reduces fuel supply for a balanced mixture and fuel efficiency. The boost pressure sensor also acts as a safeguard. If the turbocharger produces too much boost, the ECU can cut fuel or reduce turbo output to protect the engine from knocking, overheating, or mechanical damage. The oil pressure sensor monitors the pressure of the engine's lubricating oil and sends that information to the car's computer or directly to the dashboard gauge. Oil pressure is critical because it ensures that engine oil is circulating properly to lubricate moving parts, reduce friction, and dissipate heat. The sensor constantly checks this pressure and helps the ECU make adjustments if necessary. In many cars, it also triggers a warning light or gauge reading on the dashboard to alert the driver if oil pressure drops too low. The detonation or combustion pressure sensor is an advanced sensor that measures the actual pressure inside the combustion chamber of the engine. Unlike the knock sensor, which listens to detect vibrations caused by abnormal combustion, this sensor directly monitors the pressure curve during combustion in real time. By providing this precise data, the sensor allows the car's computer to make extremely accurate adjustments to ignition timing, fuel injection, and turbo boost. This helps maximize power output while preventing knocking, pre-ignition, or detonation that could damage pistons and valves. The combustion pressure sensor is useful in modern, high-performance, and downsized turbocharged engines where precise control is critical to balance power, fuel economy, and emissions. The fuel pressure sensor monitors the fuel pressure within the fuel rail and sends that information to the car's computer. This is crucial because fuel must be delivered to the injectors at the correct pressure for the engine to maintain the proper air-fuel ratio. With accurate readings from the sensor, the ECU can control the fuel pump and injectors to deliver the right amount of fuel in various conditions, whether the engine is idling, accelerating, or running at high speed. This ensures smooth performance, good fuel economy, and reduced emissions.